Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be looking at geometric series, and in particular, finding the sum of an infinite series. So let's go ahead and get started. So as you know, a series is a collection of numbers. For example, it might be, 1, and then it might go to 2, then it might go to 4, and it might go to 6, etc. And so normally, there's some sort of an end to it. So this is a finite series. However, if we have these little ellipses here, now it's an infinite series. And of course, this is not a series, this is actually a sequence right now. If I put the plus signs, now it's a series. And so when you have the little dots, how can you get an answer for the actual value of the actual infinite series? Now, this one I drew here is not the best example. This is undefined, because the r is larger than positive 1, obviously. But when we have something a little bit more practical, like for example, you start with 1, and then you go to 1/2, and then 1/4, and then 1/8, like this. This is an example of where you can find the actual sum of an infinite series, because each number, as we go further and further this way, the value of the particular term gets less and less, so it has less and less influence on the final answer. Whereas with my first example, you can see here that the value of the term keeps getting larger and larger, and so you get a super huge number that just goes off to the limit of infinity, if you will. And so what we're going to do is we're going to learn how to do this in this particular video. Now, there are several rules that I'm familiar with that you have to keep in mind when you're trying to determine if you can find the sum of an infinite series. The first thing is that you got to make sure that you have a ratio. And the ratio is, of course, when you do a over 2 over a over 1 and you get some sort of a particular value. It has to be the same between the terms. If this ratio shifts back and forth, it's not going to work. The second thing is that you have to make sure that your ratio, we call it r for short in the actual equation, or the formula, whatever you want to call it, it has to be greater than -1, but it has to be less than 1. If it does not meet that, what's going to happen is that you're going to have an undefined series, if you will, and you'll start to have problems with that. So we have to make sure that our r is between these two boundaries here so that we can have success. Now, having said that, why don't we go ahead and do an example now. So here is our pattern. So we're going to have 2 plus 2 over 3 plus 2 over 9. And then we're just gonna put our dot like that. And so we need to figure out what is the answer. Now, before we figure that out, there's one thing I forgot to mention, and that is the actual formula for finding the sum of an infinite series. And so it's going to be a over 1, a sub 1, 1 minus the ratio. That's the formula that we're going to be using. And so let's use it for this particular problem we have right here. Now, there are several things I have to figure out, or I have to collect data for. First of all, I need to figure out what is my A1. Well, that's given to me. It's right there. It's 2. I also need to know what my ratio is. I don't know that yet. So I take my formula, a over 2 over a over 1, like so. And so that means I would take 2 over 3 divided by 2 over 1. That's the same as saying 2 over 3 times 1 over 2, that equals 2 over 6, or you could say that equals 1 over 3. So that is my ratio. My ratio is 1 over 3. I took my second term divided by my first term to get that. So we have all the information. We can begin to plug things in here. So my A1, go ahead and change the color for you. My A1 is 2, a sub 1, and then the bottom is going to be 1 minus 1 over 3. Now, I need to solve this separately. I'm showing all steps here. One thing brilliant math people like to do is skip steps because they're so brilliant. And if you're a mere math mortal, you just get lost. And so 1 minus 1 over 3, well, and of course, when you get lost, the math teacher doesn't understand why you're lost because it's so clear to them. So I need to figure this out. So I'm going to make this 1 over 1 because that's the same thing as saying 1 minus 1 over 3. So I need the same common denominator. So I'm going to multiply this guy by 3. It doesn't change anything really. And so now I have 3 over 3 minus 1 over 3, which equals 2 over 3. That's very, very simple. So now this is what I have. I'm going to have the following information. I'm going to have 2, that's still my a sub 1, over 2 over 3. This is my 1 minus my ratio, my r. That's the same as saying 2 over 1 divided by 2 over 3. Or you could say that's the same as saying 2 over 1 times 3 over 2. And so what I end up having here is, for my final answer, 6 over 2. And we can simplify 6 over 2 to 3. And so that is my answer. So when we take this particular sequence here, 2 plus 2 over 3 plus 2 over 9 plus etc., when we sum up that infinite series, the final answer will be 3. That's how it works. And so you can see here, there's a lot of steps involved, but it's just division, subtraction. It's not that deep, but you have to be familiar with the steps and how to apply them in the situation. That's where it gets tricky. Let's do one more. This time we're going to do one that involves summation notation. So I'm going to have my summation right here. So it goes to infinity, of course. Our k is going to start at 1. And this is what our actual thing we're going to sum by is right here. Okay. So let's see here. I know I don't know what my a sub 1 is. I have to deal with that in a second. But I do know what my ratio is. I'm multiplying everything by basically negative 3 over 8. So let me see if I can deal with this problem of figuring out what my A1 is. To figure out what A1 is, I just take the formula that I have. Let me change the color here. I take the formula that I have and I substitute 1 where I see the k at. So negative 3 over 8 to the first power is negative 3 over 8. Excuse me. So you can see that my a sub 1 and my ratio are the same because this problem is so simple. There's not a whole lot going on in terms of the mathematics. Now I need to plug all this stuff in as follows. So I follow my formula. We saw this before. A sub 1 minus r. That's how we figure out what the sum of an infinite series is. So my a sub 1 is negative 3 over 8. And then now it's going to be 1 minus negative 3 over 8, like so. So you can see that I need to deal with the bottom first. So I'm going to deal with him over here. And you can see that it's going to be, I'm going to multiply the first number by 8. So it's going to be 8 over 8. This is just for simple math. And I have 2 negatives, so it's going to be plus 3 over 8 because the two negatives here, they make a positive. And so for the bottom number, I'm going to get 11 over 8 like so. So I'm getting close here. I'm almost done. So now I plug this back in. I'm going to have negative 3 over 8. This is my top number, my numerator, divided by 11 over 8. This is my simplified denominator. And so this is the same as, let me change the color here, negative 3 over 8 times 8 over 11. This is the negative. I know you can't see that. And so that's the same as 24, negative 24 over 88. And if you simplify that all the way down, you will get negative 3 over 11. So that is what this particular one was summed to. So if you go negative 3/8 and raise it to the first power, the second power, all the way up to infinity, it'll add up to about negative 3 over 11. That's what it'll end up being. And so, this is how you do it. And you have to look at what you have and figure out what you don't have in order to get the final answer. That's kind of the point. So let me kind of go back and summarize what we talked about and wrap up this lesson. In this video, we talked about how to find the sum of an infinite series. Now, it might seem impossible to do that, but if you remember the criteria that if your ratio is between -1 and +1, you are able to calculate it because each successive value has less and less influence on the final answer, as you can see with this guy right here. If it does not meet that criteria in which the ratio is between -1 and +1, or even if there even is a ratio because it might be an arithmetic series, then you will not be able to do that. But in this particular situation, we can. And so the first thing that we have to keep in mind is like, how do we find a ratio? We reviewed that. You take a term divided by the term next to it to the left, if you will, to get that answer. And then here's the formula for how to get the actual sum of an infinite series. S equals a sub 1 divided by 1 minus r. And then we plugged it in. Here's an example. It's messy, it's complicated, but it's not too bad. This is our sum right here, our series, excuse me. And we plugged in all the information. We knew what our A1 was. We had to figure out what the A2 was, which was essentially 3. And then, or 1 over 3, excuse me. And then when we ran the numbers, we found out that the sum of our series is going to be 3. And again, you can review the steps on your own time. And then repeated the process, but what was unique this time was that we used summation notation. So we had, 1 goes to infinity, minus 3 to the kth power. We had to figure out what a sub 1 was. We knew the ratio was supplied for us. It's right here. And so then we plugged in the numbers. We had to do some basic problem manipulation of some fractions in the bottom and just solve it, not that deep. And that is how we were able to get the answer. So I hope that this video was useful for you and you were able to understand what we talked about today. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.